Hello friends. Now we shall discuss about the contents of unit 4, that is analysis of structures. Under this unit we will have to discuss about analysis of trusses as well as cables. So let us start with the definition of truss. What is meant by a truss? Truss is nothing but an assembly of members connected to each other with the help of frictionless joints, and truss can carry load acting at the joints only. Now here on the screen, to the left of the screen, you can see a figure in which three members, member AB, member BC and member AC, these three members are connected to each other with the help of frictionless pins or frictionless joints. The joints are shown in red color, and this particular structure is carrying a point load at joint B only. So assembly of different members connected to each other with the help of frictionless joints and which carries load at the joint only is called as truss. So this figure shows a simple truss. Now truss may be a perfect truss may be a deficient truss, or truss may be a redundant truss. So what is meant by a perfect truss? Perfect truss in which number of members m equals to 2j minus 3. Now in this equation, m stands for number of members while j for number of joints. So when number of is equal to 2j minus 3, then that truss can be called as a perfect truss. For example, in this figure, we are having a triangular truss which consists of 3 members and number of joints are 3. So if you can consider the right hand side of the equation, m is equal to 2j minus 3. So 2 into number of joints 3 means 6 minus 3, and hence m is equal to 3. So this truss is having 3 members, and thus this truss can be called as a perfect truss. Deficient truss is a truss in which number of members less than 2j minus 3. Again, all these terms m, j, etc., they are carrying their usual meanings: m number of members, j number of joints. And the redundant truss is a truss in which number of members are greater than 2j minus 3. Now we will consider 3 types of trusses. First truss is a truss which consists of five members. One which consists of 5 members. 2 members horizontal, and one more member is there. That member is diagonal member. So thus there are 5 members, and if you calculate number of joints, so one joint is there at each corner, so number of joints 4. So 2j minus 4 means 8 minus 3 is equal to 5, and the truss is having 5 members, and thus the truss is called as a perfect truss. While in the second figure there are 4 members and 4 joints are there, and hence 2j minus into 4 minus 3 again equal to 5, but the truss is having only 4 members, and hence the truss is called as deficient truss. While in the third figure there are 1, 2, 3, 4, 2 members are vertical, 2 are horizontal, and 2 are diagonal members. Thus there are 6 members, and 2j minus 3 is equal to 5. So members are in excess of 2j minus 3, and this type of truss is called as redundant truss. The term redundant means in excess. So in the third truss, which is shown in the figure to the extreme right, in this truss there are 6 members which are more than the requirement. Actually the requirement is 2j minus 3, but here the number of members are greater than 2j minus 3. So here one member is in excess, and hence the truss. While in the middle figure, central figure, number of members are less than 2j minus 3. So this is deficient truss or imperfect truss. So this is classification of a truss. Now what is meant by analysis of a truss? Now analysis of truss means finding the support reactions of the given truss along with force in each member of the truss. Now as we know, each member carries a single force. That force may be either tensile, or compressive in nature. So analysis, it includes finding support reactions along with force in every member of a truss. So there are two methods of analysis which we are using. First one is method of joints and second one is method of sections. So before discussing the method of joint or method of section, now we will discuss the concept of zero force member. So what is zero force member? It is a member which is carrying no force or zero force. In case of a truss, each member is subjected to a force, single force, either tension or compression, or tensile or compressive in nature. But when member of a truss is not carrying any force, then that member can be called as a zero force member. So this is an important step in the analysis of a truss. How to identify zero force member? Now there are two points which one must know. First one is this first condition is applicable for two members only. When two members joint and that joint is not carrying any force, in that case force in the members will be equal to 0. For example, in this figure, two members are connected at joint A, member A, but that joint is not carrying any load, and hence force in member AB, force in member AC will be equal to 0. Now the second condition is applicable for three members. When three members are connected at a joint. So in the figure shown, three members are connected at joint A and joint A is not carrying any force. But out of these three members, two members must be collinear and third must maybe at an angle or having some inclination with horizontal or with vertical. So in this figure, three members are connected at joint A, member AB, member AD and member AC, and joint A is not carrying any load. So here the force in the third member, that is member AC, is equal to 0. Now we can discuss method of joints. This is a common method which is used for analysis of a truss, called as method of joints. In this method, equilibrium of each joint is considered and conditions of equilibrium are applied to find the unknown forces. Now the steps involved in the analysis are: first, find the support reactions of the truss using three conditions of equilibrium. So here in the first step, you have to apply all the three conditions of equilibrium to the entire truss. As we know, the first condition is summation fx is equal to 0, the second condition is summation fy is equal to 0, and the third condition is summation m is equal to 0. So here you have to apply all the three conditions to the truss, given truss, and find all the support reactions. Then in the second step, you should identify zero force member. See, if you are in a position to identify zero force member, then definitely it will reduce your work. If not, you can analyze the truss, but in that case you will be wasting your time. So it is always good to identify zero force member or zero force members in the truss using the two conditions which we have just discussed. Third step is, after identifying zero force member, finding the support reactions, then you have to select one particular joint at which there are only two unknowns. This is a very important condition. If at a joint there are three unknowns, then you cannot analyze that particular joint. In the fourth step, draw a free body diagram of the joint under consideration and apply two conditions of equilibrium, namely summation fx is equal to 0 and summation fy is equal to 0. Now to apply these two conditions, one must know how to resolve forces into their x and y components, and at the end, after finding all the forces, you must tabulate your result. Now let us discuss few numericals. Now here this is first numerical in which a truss is shown. Now this particular truss can be analyzed without finding the support reactions. That we shall discuss afterward, but it is a good practice to start your problem with finding support reactions. So here at support B, there are two unknown reactions VB and HB. So you can assume the directions of these unknowns, while one more unknown is there at VC. So as per our discussion, find support reactions. First apply summation fx is equal to 0. If you apply this condition, you will be having value of HB. Okay, now for HB we are having negative sign. It shows that our assumption regarding the direction of HB is not correct, but HB is acting to the right, so we can change the direction while writing the answer, or you can quote your answer as it is with negative sign. Then the second condition, apply second condition, summation fy is equal to 0. If you apply this condition, you will be having one equation in terms of VA and VB and VC. So VB plus VC is equal to 2.4. And now I apply third condition of equilibrium, that is summation m is equal to 0. Now here you can take moment about any joint, any point on the truss, but it is usual practice to take moment about one of the supports. So here we will take moment about B, and taking moment about B you can calculate unknown reaction VC, and after finding VC one can calculate VB. Now the actual analysis starts. So here you have to select a joint where only two unknowns are there. So if you consider all these joints, if you consider joint A, there are three members. Three members are connected at joint A. It means that at joint A there are three unknowns. So you cannot start with this joint, because we are having only two conditions of equilibrium, and using two conditions of equilibrium or two equations we cannot solve a problem having three unknowns. Now joint B. Now at joint B there are two unknowns. One unknown is force in member AB, second unknown is force in member BC. So you can select joint B. Consider joint C. At joint C there are three members connected at joint C. So all these three members are carrying unknown forces, so there are C. So again C cannot be considered. And at joint at joint D, only two members is that joint D carries two unknowns. So consider free body diagram of joint D, which is shown on the right hand side of the screen. So draw free body diagram of joint D. Now at joint D there are two unknowns, force in member AD and force in member CD. So assuming that all these unknowns are tensile in nature, draw a free body diagram of joint D and apply conditions of equilibrium at joint D. Applying summation fx is equal to 0 and fy is equal to 0, you can determine the two unknowns. So thus these two unknowns can be obtained. And now let us move to joint C. Now we can consider joint C, because at joint C though three members are connected, now we know force in member CD, and hence there are two unknowns at joint C. Now draw free body diagram of joint C again. First force acting at C is reaction VC in upward direction. Second force will be FAC. Third force will be FCD, which is known to us, and next force will be FCB. Applying summation fx is equal to 0, fy is equal to 0, you can find the unknown. Now here, since force in member AC and BC, these are the two unknowns, one can assume tensile directions for these two unknowns, or using your logic you can select correct directions for all these two unknowns. If you consider tensile direction for FAC and FCB, in that case your answers will be having negative sign. So you can use your logic to assume suitable directions for these unknowns. And now at the end you can consider joint A as well as joint B. At joint A now there are two unknowns, there is only one unknown FAB, or at joint B only one unknown is there FAB. So here I have considered equilibrium of joint A, and again applying conditions of equilibrium we can calculate all these unknowns, and at the end you have to tabulate your result. In first column will be serial number, second column will be member, then force in the member and nature of the force, either tensile or compressive. Okay, second problem which you should try following the same conditions. Okay, this is method of sections. which we shall discuss in the next lecture. Thank you. Thanks a lot.